But here is the username, password coming up on the screen. So remember to log into Buzz. You need to use your first part of your email, and then online 2021 capital O. So if anyone cannot get onto Buzz, make sure you let me know so I can make sure that is fixed. I'll leave it up there for a minute so you can check it out. But as I say, several of you have already been on there. And there's a link to Buzz on the front page of Google Classroom. You look down at the bottom of the screen, you see that blue link that I posted. It's got a blue icon, for that link for Buzz. So just making sure you can get on there. But today we are going to talk about lesson 2 that's in our activities for the week. And lesson 2 is solving systems of equation graphically. Last class we looked at solving systems algebraically, and now we're going to look at graphically. And I thought I better back up for just a minute because here I am talking about solving systems, and we haven't really defined what solving an equation is. What is a solution to an equation? Okay, I'm going to present that. So if I put this equation up here, 2x minus 3y equals 6, and I say, what is a solution to that equation? Because we talk about solving a system of equations, solutions, but let's just talk about solving just one equation. Can anyone tell me what a solution to the equation, what does it mean to find a solution to that equation? You can put it in the chat, or you can turn on your microphone. What's it mean to find a solution to that equation? Yes. Numbers that will make x and y true. Yes. Okay, let me phrase that a little differently. A number for x and y that will make the equation true. Yes, a number that we can put in for x and a number we can put in y, that when you put those in there, it does equal 6. So we're looking for that. So with that, what if I propose 4 different possible solutions? And we say, okay, we want to know, is this a solution? So if we look at x equals 0, y equals -2, can we find out if that's a solution? Sure we can. And there's more than one way to do it. We can just take this x and substitute it in, and take this y and substitute it in, right? So we could say 2 times 0 minus 3 times -2 equals 6. Well, 2 times 0 is 0. -3 times -2 is a positive 6. Oh, looky there, 6 equals 6. So that is a solution to that equation. So we could do the same thing with all 4 of those, and that would be finding the solution algebraically. But I said today we was going to talk about finding the solution graphically, and we can do this exact same thing if we just make these points and graph this problem. So if x is 0 and y is -2, that is the point 0, -2, right? The x is 0 and the y is -2. So this would be the point 3, 0. This would be the point 4, 1 and 6, 2. All right, so I can make all those points and then we can graph it. So now I'm going to pull up graphing online, and I need to put this link on our Google Classroom too. I have not done that yet, but I will do that. I will add this link. But a great site to use is desmos.com, DESMOS. They have a great graphing calculator here that you can graph equations, points, all kinds of things. And see over here on the left, you see I have the equation type 2x minus 3y = 6. That was our equation. Now it hasn't shown up on here because I've got it turned off. You can hit this little circle and turn things on and off when you graph. So I'm going to turn it on. There is the graph. All right, there is the graph to 2x minus 3y = 6. Right now, if we were graphing that on paper, we would probably rearrange that so it's y equals, and it'll give us a y-intercept and a slope. But in Desmos, I can just type it in as it is, and it will graph it for me. And here's that point we checked, 0, -2. If I turn it on, look, there it is right there. There's 0. I'll label it so we can see it. There it is, 0, -2. It's on the line. So we know it is a solution because this is the graph that line. So all these x's and y's that are on that line are going to be solutions to that equation. 3, 0. If I turn on 3, 0, label that, there it is. 3, 0 is a solution to this equation. Let's look at 4, 1. If I turn on the label, 4, 1 is not a solution to the equation because 4 times 2 is 8 minus 3 times 1. So 8 minus 3 is 5. It's not 6. So that is not a solution. 6, 2, that is on the line. So that is a way to find a solution to equation graphically as opposed to having to do it algebraically as we did it last time. So let's talk about systems of equations and solving systems, which is what we've been studying this week. We looked at how to solve several of them on last class algebraically. Let me go back to this other screen because I do have something else I want to look at just before we get into that type of a system. I want to look at one other option. What if we have, before we get into systems, or is it before? Sometimes we still just have one variable here. I want to solve that for x. I want to find the solution to this. 5x minus 11 equals -2x plus 3. Now, I can do that algebraically because this one's pretty simple, right? It's pretty simple. I can move the x's over here. I can move the 11 over there. I can divide or whatever I need to divide, get x by itself and solve that. But I can do this as a system because let's look at this. What if this equation, I'm going to call it y equals 5x minus 11. And this equation, I'll say is y equals -2x plus 3. So basically I'm saying y equals y because I'm saying these equations are equal to each other up here. I said there is an x where these will be equal to each other. So y equals y, right? But if I substitute this, y equals y, this is y, this is y, I have a systems of equations now. And I can graph that and get the answer as opposed to algebraically. So let me switch back to mother screen because I have this already on our Desmos calculator as well. What is the x that is true for both of those? That will make it true for both of these right here. So there is the 5x minus 11, y equals 5x minus 11. And when I turn that on, there is the graph of y equals 5x minus 11. If I turn on the other one, then -2x plus 3, there's the graph of that. Right here, they have the same x. So x equals 2 is on both of those. They will be equal when x equals 2. Both of those equations will be equal when x equals 2. Now the y happens to be -1, but in our original equation, we didn't have any y's that we had to determine, but we had to figure out what x would make those two equations equal, and it's when x equals 2. So we can solve that just by graphing the two equations, turn it into a system of equations. See, we weren't getting away from systems of equations. I was just showing you a different type of system where we only had one variable until we set them both equal to y. We set them both equal to y as opposed to equal to each other. So when x equals 2. Let's look at a different system. All right. Let's suppose we have x minus y equals 3. And we had 4x plus y equals 2. All right. Last time we looked at that, and when we see those two equations, x minus y equals 3 and 4x plus y equals 2, we think that would be a good one to do by elimination, right? We add those together, that y is going to go away. I've got a negative y and a positive y. They're going to go away. I can do this by elimination. I can also do it by substitution. If I want to add y to both of those, I got x equals y plus 3. But again, that's a lot of algebra when I can just graph them like this, boom, boom, and find out where they cross. That is the solution. That is the x and the y that will make both of those equations true. X equals 1, y equals -2. That's what we did last class, man. We did it by elimination, and we'd eliminate the y, and then we'd figure out what x was. We get 5x equals 5, divide both sides by 5, figure out the x equals 1. We would take that 1, we'd put it back into one of the equations, then we would solve that equation for y. We'd end up with -2. Where instead, this time, just by graphing those two equations, the graph shows us right there the solution to that system of equations. Oh, very nice. All right, let's look at a different example. Now, this is one that if we did this algebraically, whether we did it by elimination or whether we did it by substitution, we would end up with, let's see, if we did it -2y, we would end up with one of those problems like it's 2 equals 2, where everything went away. We didn't get an x equals something or a y equals something. We ended up with like 0 equals 0 or 4 equals 4. And we talked about how that would have infinite solutions. That's what we figured out algebraically. If we get something that's true, 3 equals 3, whatever it ends up being, infinite solutions. So what's it look like when we graph to know that we have infinite solutions? Well, here's the graph right there of the first equation, that red one. All right, let me zoom in a little bit. Here's the red one. Now look where the graph is of the blue one when I turn that on. It's the exact same line. That's why we said there was infinite solutions. Where do these two lines cross each other? They cross each other at an infinite number of places. If we zoom out, they're the exact same line all the way. So that's why there's an infinite number of x's and y's that will satisfy both of those equations and make them true. Now, it's not just any x or y, all right? It's not just any x or y. If I click right here, oh, sorry, -2, -3 works. But if I clicked up here, -2 would not work because it's not on the line. But there's an infinite number, all of these, even the little decimal ones, there's an infinite number of x's and y's that would make both of those equations true. Okay, let's look at another option. How about this one right here? Y equals 3x plus 2 and y equals 3x plus 1. If we solve that by substitution or elimination or however we want to solve it, we will get one of those equations that says 0 equals 3. And we would go, 0 equals 3. No, that's not true. That's not a true statement. That's one of those that we said that there's no solution. We said there's no possible x, y to make those true. And when we graph that, we can see what it's talking about, because when we graph them, they don't touch. We can zoom out all we want. They are two parallel lines, and they never touch each other. So there is no x, y point that they have in common. None at all. So that's why when we solved it, we come up with no answers. We come up with like 0 equals 3. which didn't make any sense because 0 doesn't equal 3. And that's because there's not any point they have in common when you graph them. So we can see graphing, you can have parallel lines with nothing in common. You can have the exact same line with every point in common, an infinite number. We have your standard solution, which is just one solution, because with lines, that's your only three options. Either they never touch, they touch everywhere because they're on top of each other, or they only touch once. There's no way they can touch 2 times or 3 times because they're both straight lines. They're only going to touch in one place unless they're the same line or parallel lines. So that's your only 3 options when you're dealing with lines. Now, if we get into quadratic equations and other equations, then you got all kinds of possibilities. But we're just talking about 2 linear equations, 2 lines. Our options are one solution, no solutions, or infinite solutions. All right, and then remember we took the one where 5x minus 11 equals negative 2x plus 3. Figured out we could solve that by graphing. And then, of course, just the solution. Any point on the line is a solution. Any point that's not on the line is not a solution. So when we talk about a solution, we a lot of times think about just the math part of it, but graphically it means something. It means that point is on that line if it's a solution. So that is the big overview of lesson 2. I say probably simpler than lesson 1. We didn't have to use a whole sheet of paper, just solve one problem like we did algebraically. But we could just use a graph. Now, if we had graph paper, we could graph all of those by hand, but that's not the point, knowing how to graph. The point is knowing what it's telling us. So that's why we went in and did it electronically. I will post the graphing site on our website. You may already have it. You've probably used it before, but I'll put a link to it on our classwork page on Google Classroom. But otherwise, these assignments are due Sunday. Let's see, we've got system equations. I'll put another video for today on there. This week, what you have to do is the pretest and then the lessons 1 and 2. Those are due Sunday by midnight. Don't wait till midnight. Work on them today, work on them tomorrow, get them done. Enjoy your weekend.
Let's get out of here. Word to your multiples. Math, baby. We're learning math, baby.